Welcome students. Today we'll discuss oxidation and reduction, and this discussion will help mostly the 7th and the 8th standard of West Bengal Board of Secondary Education students. So this chapter, oxidation and reduction, comes under the chemistry portion of the physical science book. There are two ways of understanding oxidation and reduction. One is the conventional method of understanding, and the other one is the electronic method of understanding these two physical and the chemical processes. We will first discuss about the conventional method of understanding oxidation and reduction. So, what is oxidation? Oxidation means the chemical attachment of oxygen or any electronegative element or some substances, maybe in some cases, with other elements and compounds. And during this process, a little or huge or no energy may get released. Most of the examples of oxidation that happens around us are in the form of combustion or very slow process of combustion, which is known as rusting. Let us first discuss about the combustion process. Combustion is actually chemical reaction of inflammable substances with oxygen, which is often called burning. During this, smoke and heat is released. Fuels contains carbon and hydrogen along with the other elements. Whenever we burn fuels in open atmosphere, that is in presence of oxygen, that carbon of that fuel molecule reacts with oxygen to form carbon dioxide, that is the smoke, and a huge amount of energy. And again, the hydrogen of that fuel molecule also reacts with oxygen to form steam, that is the water vapor, and energy. A simpler example may be of that of methane. When methane reacts in open atmosphere, that is with oxygen, it forms water vapor, carbon dioxide, and loss of energy. Let us now discuss about rusting. Rusting is also a form of oxidation. It occurs very slowly. In a sense, it can be said a kind of slow combustion with very little or no energy on offer. Let us take the example of rusting of iron. When iron is exposed in open atmosphere, that is an exposure to oxygen and moisture, can result in rusting. Rust, that is ferric oxide and NH2O, is not iron, and in a sense it annihilates or corrodes iron. Long exposure of materials such as bronze, copper can also result in corrosion, that is oxidation, that you can see in the picture, along with some other examples of a rotten apple, which is the oxidation of its lipids, and all forms of oxidation and reduction. Reduction, on the other hand, in contrast to oxidation, in reduction, oxygen is needed to be detached or replaced. So whenever oxygen is replaced, reduction occurs, and oxygen is often replaced by hydrogen or any other electropositive substances such as metals like sodium, potassium, etc. In the very first example, we can see cupric oxide being reduced by hydrogen as hydrogen replaces the oxygen. In this case, we can either say cupric oxide been reduced or simply copper been reduced. In the second example, we can also see nitrogen is reduced by hydrogen to form ammonia. So in this manner, reduction is a very simple process where hydrogen or any other electropositive metals or substances getting attached to free molecules or free atoms, or in the other hand, oxygen or any other electronegative materials are getting detached or replaced by them. Let us now discuss which are oxidizers and reducers. Well, oxidizers, these are the substances which oxidizes others and get reduced itself. Oxygen and the other electronegative substances are such examples, and reducers on the other hand are just opposite to the oxidizers. they reduces others and oxidizes itself. Hydrogen and the other electropositive materials are such examples. Oxidation and reduction occur simultaneously during a chemical reaction. You can see from the first example of ferric oxide and carbon monoxide. While reacting, they form the metallic iron and carbon dioxide. In this case, ferric oxide is reduced and carbon monoxide is oxidized to carbon dioxide. From that analogy, now students, you can do it yourself, and you have been given the famous thermit method of reaction by which we can extract iron. Try to find yourself which one is reduced and which one is oxidized in this case. Now we have the electronic method of understanding of oxidation and reduction. In order to have stable electronic configuration, atoms either donates or accepts electrons. When atom donates electrons, they are said to have gone through oxidation. Just look at the first example where iron donates 3 electrons to form ferric iron. So in this case, iron is said to have been oxidized. And in the second reaction, we can see oxygen accepting 2 electrons to form oxide ion. In this context, 3 examples have been given to find out which one is reduced and which one is oxidized, and do it yourself as homework.